Lesson 5-2, Special Cases of Absolute Value Equations. Here we have the absolute value graph, which is f of x is equal to the absolute value of x. One thing that is unique is as you plug in positive values, your line is positive. As you plug in negative values, your line is also positive. So that's why it looks like a V shape. All right, so we have possible solutions. We have two solutions when here the absolute value of x is equal to 3, right? Because this is the absolute value, the V shape here of the graph, and this red line is 3, we end up having two solutions, one right here and one right here. Now, if the absolute value ends up being 0, as in the second graph, that is the absolute value of x is equal to 0, we have possible solutions just at one single point. Whenever this happens, whenever you have anything inside of the absolute value, you end up with one solution. And that is because normally you would set up two equations, the positive and the negative solution. But in this case, because this is 0, you only have one solution. Now, if you were to run into something like this, where there is no interception, you have your absolute value here, and this line is some negative number, like this. We have the absolute value of x is equal to -2 in this case. Well, as you might imagine by the title, this has no solutions. In fact, anything that is isolated by the absolute value, anything inside, can never be equal to a negative number. So in this case, if you run into the absolute value of anything being equal to any negative number, there will be no solution. Example number 1. Let's isolate the absolute value first. First, we need to divide both sides by 2. Remember, never distribute any number to inside of the absolute value. And that is because we don't know whether this x is positive or negative. So we're going to apply inverse operations and isolate the absolute value first. If we divide both sides by 2, then these two will end up canceling each other. And I can rewrite this as the absolute value of x plus 4 plus 3 is equal to 6 over 2, which is 3. Now I can subtract 3 from both sides. So if I subtract the 3 here and here, that ends up being the absolute value of x plus 4 is equal to, well, 3 minus 3 cancels out, and 3 minus 3 cancels out, so 0. Now, because the absolute value here is equal to 0, I can try to set up two equations, but I won't be able to because there is no positive or negative solution when it comes to 0. There's only one solution. So here's what I can set up. I can set up x plus 4 is equal to 0, and that is the only equation that I can solve for. If I subtract both sides by 4, then my solution is going to be x is equal to -4. Okay? In this case, one solution is fine as long as the absolute value of anything is equal to 0, and that is after I apply inverse operations and isolate the absolute value. Go ahead and try this problem on your own. You can pause the video. All right, so let's apply inverse operation. Here's the absolute value. We're going to isolate this first. So let's subtract 10 to both sides. Okay, and that gives me -10 times the absolute value of -8, k, plus 4 is equal to, well, 10 minus 10 is equal to 0. Okay, I'm not done yet. I'm not done isolating. If I divide both sides by -10, like this, then these -10s are going to cancel out here. And I have the absolute value of -8k plus 4 is equal to 0 over anything is 0. So now the special solution applies. This is isolated and this is equal to 0. So I know that there will be only one solution. If I set up that one solution, I have -8k plus 4 is equal to 0. And I'll just be solving for k. So if I subtract 4 on both sides, the 4's will cancel out. And I have -8k is equal to 0 minus 4, which is -4. Then I have one more step equation here to follow. So divide both sides by -8. And k will equal, well, negative over negative gives me a positive. And 4 divided by 8 is really simplifies down to 1/2. So this is my answer. K is equal to 1/2. All right, example number 2. Now this problem is going to be an example where we don't have a solution, and it's pretty easy to tell when we don't have a solution, okay? So let's apply inverse operations and isolate the absolute value. So here the absolute value is being, we're adding 4 to this, so we'll subtract 4 on both sides. All right, so that gives us the absolute value of -5x is equal to the sum of these two. -11 minus 4 is -15. And we're pretty much done. After you solve for the absolute value inside without having any other operations outside, if you're isolated with the absolute value and that is equal to a negative, you automatically have no solution. Okay, no solution. Why? Because any number that you can plug in, and you can think about any number, you plug in here, whatever you get, always after evaluating the absolute, is going to be positive, any positive number, okay? Doesn't matter what you plug in here. And that cannot be equal to a negative, any negative number. So we can put that, okay? This has no solution. All right, here's the last example of today. Apply inverse operations first, isolate this, and then this is going to be a no solution problem, but try to see why it won't be. You can pause the video. All right, now that we're back, let's apply inverse operations. So isolate the absolute value. We'll subtract 7 on both sides to begin. Okay, and then we have 3 times 1/2 x plus 5 is equal to, the 7's canceled out. 5 minus 7 is -2, right? I have one more step in order to isolate the absolute value. So I'll divide both sides by 3. Okay, these 3's are going to cancel out. And that just leaves me with the absolute value of 1/2 x plus 5. All right, the absolute value lines are isolated. And here I notice that they're going to be equal to a -2/3. It's a fraction. And because we established that any number here, right, doesn't matter what operations we apply, any number that is evaluated by the absolute value operation is going to be positive. So this cannot happen. Okay, this is not valid. Okay, if you try solving for x, you're going to get a value here, but once you try plugging it back in, it's not going to match up with the negative answer. Okay, so because this is a positive number, okay, and this is negative, that cannot be equal to, there won't be no solution. All right, so to review and summarize, we have two solutions when we have some positive number, okay, for absolute value. We have one solution when the absolute value is equal to 0, and we have no solution when the absolute value is equal to negative numbers.